One, two, one, two, one, two, one, two, one, two. Woo!
Hello guys, and welcome back to this one. So today we are going to be looking at the optimization of this code, and we are going to be making use of heaps to solve the problem as against what we were doing before checking all the lists. So we see how here that the optimized approach uses a heap such a priority list to cook. So we call it the k-way merge. So the pattern we are going to be using here today is the k-way merge, and the trick is in what we pour from the heap, we know we are to insert in the final sorted list, right? So whatever we pull from the list, that's also we know that we are going to pop we are going to that's our, like, either our print or we put it in a sorted list, but basically to enter into a sorted list. And then we say, but how do we know what list our pop comes from, so that we know what file to add to the heap from? Is the bone of contention, right? So basically, what he's saying is that, okay, when we pop out from the heap, how do we now know the one? Because you know that the heaps move around based on what you put in them. So how do we now know exactly what the file that we just picked from, so that we can collect from that file again to update the heap? So that's right, literally a bone of contention. Yeah, everything will begin to make sense with graphical illustration. So we said merge sorted list. Obviously, we imported our heap. We said merge sorted files. So we call the files, it's a list of lists. Yeah. Um, right. Yeah. So it's a list of right integers. Right. Yeah. So you could have integers here as well. Yep. So yeah. So yeah. So we say mini heap. So we create our mini heap. So we are going to be making use of this mini heap to help us, and we know we're going to get to complexity eventually. So what do we do first? So we say for file index in range files in the length of files within the files, we say if files at that specific index is greater than 0. So we are just making sure that, this is a conditional to make sure that if that file has a value, at least one value, we now say heap the push mini heap. So we are going to be pushing into this mini heap the the value at that index that we are looking for, which is index at 0, file at index of 0. So we get that value, we get the file index and the 0. Basically, the way I envision it is like, the guys that help us to the location, right? Just as we said, how do we know the location we port from? These are the guys that will help us by knowing this file index and knowing the index within the file. Then we know that location. So we now see, after getting all the first boys into the heap, so all the first index values into the heap. Now we can now start running our iteration. So we now say while mini heap. So what there is something within that heap. What do we want to do? We want to say um, value index, file index, and the index. So we pop it out. So by popping it out, we are going to be popping out the minimum value immediately, because the heap by itself would solve that problem of which one is the smallest for us. And then we say print out the value. So when we print out the value, we know we are printing out the least value from the heap, because that's what the mini heap does, right? And we'd say next index is equals to index plus 1. So because we know that value, that this one we just printed out, this value we just printed out on the heap, right? We need to move on the index, right? So we increase the index here, and then we now see if that index is less than the length of the file index. Why are we doing that? Just so we make sure that our file is not greater than the index we are trying to, is our file is not less than the index. Imagine looking for index or at 2 when your file ended at a file length of 1. So we just make sure that we have that file has, because these files can be 3 values, 2 values, 1 value. You should be able to accommodate even if variations in file lengths. Now we say, what do? We push into that heap again. This time around, we're going to be pushing in the file. We're going to be pushing in the file at that next index, and then the location, how we locate it, which is the file index as well as the next index, which now answers the question of our the bone of contention, which is when I pop a file out of a list, how do I know for the file where I'm bringing it? I brought that one from so that I can replace it. Basically, this is it here. We are basically using a tuple to hold the file value and also the location and how to locate the file, so that when we pop out the file, we just simply increase the index and boom, we have pushed into the file again from the file that we popped from. So that's basically it. So yes, that's it for this one. Tomorrow I'm now going to be looking at the graphical illustration, so where we see the ideas come together before we go to the debugger tool, where the values go through the code and we see how the solutions come to life. So yeah, that's it for this one. Muchas gracias. Bye.